Hello everyone, this is Javeria Ahmed, roll number 2022 CE10, student of computer engineering at UAT Lahore. So today our main topic is design patterns. Design patterns are reusable solutions to common problems in software development. By learning and applying these patterns, developers can write code that is consistent, easy to maintain, and effective. This lecture explores some of the most common design patterns, explains their purposes, and provides real world examples of how they are used in practice. So, now I will discuss the lecture in detail. Okay, now, now we have builder pattern. Okay, so in start, I will just, okay, now we have a builder pattern. This, okay, the builder pattern is used when constructing complex objects. Sometimes using constructors to create objects can be limiting, especially when we need flexibility. The builder class helps solve this problem by allowing step-by-step object creation. For example, Java string builder and HTTP request builder let developers build objects gradually and customize them as needed. The key advantage of this pattern is that it separates the process of object creation from its actual structure, making the code cleaner and easier to maintain. These were examples, these are nodes, and now we have factory method. The factory method pattern is a way to create objects without specifying their exact class. Instead, a factory method returns the appropriate object based on on the situation. This approach allows developers to add new subclasses without changing existing client code. For example, in Java, the method character set char set for name UTF-8 uses this pattern to return the correct character set. By using factories, developers can simplify object creation and support polymorphism more effectively. Now we have resource management, RAII. Resource acquisition is initialization. Resource management is an essential part of programming, especially for handling memory, files, or logs. The RAII pattern ties resource management to the lifespan of object. When an object is created, it requires the resource, and when it is destroyed, the resource is released automatically. This is seen in C++ with tools like unique PTR and lock guard. In Java, with try with resources, yes, and in Python with the with statement. This pattern reduces the chances of resource leaks and makes the code more reliable. Now we have singleton pattern. The singleton pattern ensures that a class has only one instance throughout the program and provides a way to access it easily. To implement this, the instructor is made private and a static method is used to manage the single instance. This pattern is often used for managing shared resources such as configuration settings. However, it has drawbacks like difficulties in testing and potential thread safety issues, making its use controversial in some cases. Now we have this is the example. You can see it in detail as well. Now we have okay, this was Paul, and yes. So now we have composite pattern. The composite pattern is useful when working with structures like trees, where both parent and child nodes need to be handled uniformly. This pattern defines a common interface for all components, whether they are individual elements or composed of other components. For instance, in a tree structure, both parent nodes and leaves can implement the same methods, like calculating depth or checking if a value exists. This pattern makes the system easier to extend as new components can be added without changing the existing code. This is basically a class diagram of composite pattern. So yeah, you can see that the component has a relation with this composite, and here's we have client and leaf and composite both have relationship with that component. This is an example. Now we have visitor pattern. The visitor pattern helps add new functionality to existing classes without modifying them. This is achieved by creating a visitor interface that defines methods for each type of class. Classes then accept visitors, delegating the new functionality to them. A real world example is uh, yes, a real world example is Java's file visitor, which handles different types of files systematically. This pattern makes it easy to introduce new operations while keeping the existing class structure intact. Now we have facade pattern. The facade pattern simplifies complex systems by providing a single unified interface. Instead of exposing the details of lower level components, the facade um, class offers a high level interface that hides the underlying complexity. For example, in a layered design, a facade can standardize how high level functionality is performed while ensuring that lower level changes do not disrupt the system. This pattern reduces coupling and makes systems easier to work. This is a figure you can understand more in depth with this figure. This is Paul. Now we have programming. Okay. This is past CS 5150 advice, not our. Now we have programming. Okay, this is not our main concern. Yes, static analysis for quality. Static analysis is a method to check source code for errors and quality issues without running it. Tools like linters and compilers warnings help identify potential problems such as dead code, unhandled cases, or null pointer errors. By incorporating static analysis into the development process, teams can catch issues early and maintain high quality code. So this is an example. Here you can see we have to suppose some things in this example. Let's suppose we have a function here which with whose return type is a boolean, like a boolean value, and yeah, so we have to return a true or a false. And if we have only this if statement in it inside the function, then we can see that it is showing false, true, and then false. But this else is not mentioning that with which if this is like this is with each with which if like with which if this else statement is making the return false. Okay, so sorry about my language. So yeah, so yeah, if we can see, we can also mention that this else statement is with if this if statement, or this if else statement is with this if statement. But in both cases, we get an error, which is that return type is not mentioned or return type is null, kind of this error. So why? Because in this case, if we assume that else if this else is with this if statement, if this if statement is false, then we have no any option that which boolean value will be returned. So yeah, will this always return? So yeah, this will not always return, which will result in kind of error, which like we mostly see in IDEs. There is a red line below the function, and when we click on that function, when we click on that line, it shows that there is some error, or return type is not mentioned, or return type is null, or this kind of. So yeah, these problems are because of this kind of um, low quality code. Okay, bugs and etc. Now we have style guides. This is case study style automation. Style guides ensure that code across a team or project looks consistent and is easy to read. Automation tools can enforce these style rules, automatically saving time and effort. For instance, tools can reformat a code to match the desired style or flag areas that need attention. Combining style guides with automation makes it easier to maintain code quality over time. So this is all from my side. If you have any problem, you can ask in comment section. Thank you so much.